Assalamualaikum, my name is Muhammad Rizman, and today I'm going to present to you my research paper titled An Application of NNARX in Modeling a Solar Radiation Prediction. So this is my slide arrangement. Start with an abstract, followed by introduction, literature review, methodology, results and discussions, and end with the conclusion. Solar energy defined as a radiant energy which emitted by the sun. Recent trend shows that solar energy had been an alternative power source to generate electricity using photovoltaic system. Solar radiation is the key measurement for this potential solar energy source, but with the high cost to build and maintain the infrastructure, had embarked a new chapter with the implementation of prediction model. Many prediction models have been developed using various methods including machine learning method and artificial neural network approach. Solar radiation prediction involves various nonlinear parameters. That is why a nonlinear artificial neural network method had been used. Nonlinear neural network autoregressive model with exogenous input (NNARX) is a dynamic artificial neural network method and have been widely applied to solve a nonlinear dynamic time series prediction model. This paper will develop a NNARX to perform solar radiation prediction using both meteorological and measured data parameter for Malaysia. Performance analysis will be carried out using mean square error calculation based on actual and predicted data gain from the approach. Solar radiation spectrum divides into 3 bands with different amount of composition consists of 42.3% visible light, 49.4% infrared radiation, and 8.3% ultraviolet radiation. There are several factors that comprehend the solar radiation intensity, such as the geographical data of latitude and altitude of the sky, meteorological data of season, weather reflected by cloud cover, and the time of the day. Solar radiation is not propagated directly towards the surface of the Earth. It tends to be absorbed and reflected by the particle in the Earth's atmospheric layer, resulted to be scattered outside of the Earth's surface. The remaining solar radiation that managed to reach at Earth's surface is defined as a direct solar energy, while the solar energy that scattered as it enters the atmosphere is defined as an indirect solar radiation. Solar irradiance defined as an intensity value of solar radiation which managed to penetrate atmospheric layer of Earth. Solar irradiance measured by the total amount of radiant flux denotes as watts per meter square. Solar irradiance measurement depends on several factors: elevation above the sea level, angle of the sun on particular time, and the cloud covers condition as the scattering elements. The elevations defined as the distance that solar irradiance travel between atmosphere and surface of the Earth. If the elevation is high, it will have a short traverse distance. The angle of the sun defines the surface of the dedicated location towards the sun. It depends on the seasons, time of the day, and the latitude of the location. Artificial neural network is a method of prediction based on biological human brain. It consists of input layer, hidden layer, and output layer. There are two divisions of the artificial neural network. One is a static artificial neural network, which is defined as a feed-forward prediction, and the other one is the dynamic artificial neural network, which is defined as a backpropagation prediction. Example of the static ANN is a radial basis function neural network, multi-layer perceptron neural network, and convolutional neural network. Example of dynamic ANN is the neural network autoregressive with exogenous input, recurrent neural network, and time delay neural network. In this study, we are using NNARX for developing the solar radiation prediction model. The figure shows that the similarities between configuration of neuron in biological brain which inspired the creation of artificial neural network model. Nonlinear neural network autoregression model with exogenous input (NNARX) is the current dynamic network with feedback connections and several layers of the network. It is based on ARX model which applies in time series modeling. There are two architectures of the NNARX, which is parallel and series parallel. Parallel architecture is defined as a closed-loop architecture, which the output from the network is feedback to the feed-forward network as an input. The prediction is performed with the combination of present and previous input and feedback from the past predicted values in form of time series. Series parallel is defined as an open-loop architecture, where the true output is created during training without the need of feedback for estimation. The prediction is performed with the combination of present and previous input and additional trained past output value in form of time series. The figure shows both of the architecture of the NNARX. Training algorithm is needed to perform the neural network programming algorithm. There are numerous training algorithms that can be used for neural network approach, but in this paper, we are using Levenberg-Marquardt as the training algorithm for solar radiation prediction. In this study, we are using MATLAB software R2019A with the neural network toolbox. In this study, we are using 5 parameters which is obtained from the Sourcast database for Malaysia, which is solar irradiance, azimuth angle, zenith angle, sunshine measurement for daily basis, and sunshine measurement for hour basis. This is the methodology flowchart for the approach. Starts with input normalization, training and generalization process, testing process, and lastly the performance evaluation based on predicted and actual values obtained. To preserve time dependencies, cross-validation applied where the training of time series data is partitioned into 10 folds. Each folds are the combination of training set and a randomly sampled test sequence. The performance of combination of different hyperparameter value is evaluated using one step ahead calculation based on MSE values. The Levenberg-Marquardt function used for weights update for each neuron to avoid overlooping problem. The performance of NNARX approach for solar radiation prediction shown in the statistical analysis. The statistical analysis carried out by using the MSE values and regression analysis. The MSE shows integer difference between actual and predicted value, while regression analysis shows the accuracy between actual and predicted value. Figure 1 shows the results of epoch produced by the training algorithm based on NNARX network. The best validation performed for the NNARX model is found at epoch 10. Figure 2 shows the variation of gradient error, value of mu, and validation checks for 20 iterations of NNARX model developed. Entire results produced by using Levenberg-Marquardt function on MATLAB software. Figure 3 shows the regression value obtained for NNARX model with the value of 0.93 found at epoch 10. The final output produced is shown in the figure, indicating that solar radiation prediction is successfully carried out using NNARX on MATLAB R2019A software with the MSE value of 0.0116. Entire values are normalized with the maximum solar radiation is stated as 1 using a sigmoid transfer function. As for the discussions, the Levenberg-Marquardt function is proven to be better than Bayesian regularization and scaled conjugate algorithm based on solar radiation prediction model. Cross-validating is required to be used as an optimal sliding windows selector. The optimal sliding window size is important as the cyclical nature of time series trends may given certain lag predictors. The hyperparameter combination with the restricted window size of 2 lakh and the hidden layer size limitation had given the best performance model based on MAC calculations. Weather effect is covered by the cloud profile, which is included in the sunshine based measurement. As for the conclusions, this paper successfully demonstrates the application of NNARX in modeling solar radiation prediction values. The NNARX model developed using Levenberg-Marquardt function, and it is shown that this model had given a significant result with the MAC value of 0.0116 as compared with the actual solar radiation values. For future recommendation, it is suggested that the hybrid approach of NNARX developed for solar radiation prediction to enhance the prediction with more input parameter. With that, I end my presentation. Thank you.